So this is still section 10.5, which is the last section we're covering this semester, so I'm sure that has you guys excited. And we're looking at how to use determinants right now, and then the next part we're going to look at how to use an inverse matrix to help us with doing a certain type of problem. So there are different uses for these things. So I'm trying to come up with some stuff that relates to stuff that you've done before. So if you are given 3 points and told that these are the vertices of a triangle, how do you find the area? Well, typically, if I gave you 3 points, if I gave you a point here, a point here, and a point here, I gave you the coordinates of those points and said find the area of this triangle, you would have to figure out, one, you'd have to figure out like what's the length of this base here. That would be a distance formula problem. So remember the distance formula, square root of x2 minus x1 squared plus the difference between y2 and y1 squared, and then you take the square root of that, you'd figure out what that distance is. So you'd have to find the length of the base. Then you'd have to figure out how far it is from this vertex here down to that base. You'd have to find the height. So you can do 1/2 base times height. Instead, we can actually use a determinant to figure it out. So you're going to take the first point. So if this is x1, y1, the coordinates of this point, you're going to put that in right here. And if this is x2, y, and it doesn't matter what order you put these in, by the way. So let's say this is x2, y2, that's going to go right here. And then if this is x3, y3, I thought I picked a different color, but red does not seem like to let me choose that. But you put that right here. And then notice the last column is just ones. Okay? So you can use this to find the area of the triangle. You're going to do that determinant. The 1/2 has to do with the fact that if you don't do that, what you're really finding is if this was a parallelogram, if there was some other point out here, you'd only need 3 of these points to figure out the area of that parallelogram without doing the 1/2 here. Okay? So the 1/2 then gets it to be the area of the triangle. The plus or minus does not mean there's 2 answers. The plus or minus is because if you, depending on what order you choose to put these in there, you might get a negative value. If you get a negative value for the determinant, then you use the negative 1/2 so that your area comes out to be a positive value. Okay? If the order that you put them in gives you a positive value, then use the positive 1/2. Okay, that's the only reason that that's there. So we could have just as easily said, hey, just make sure the area is always a positive number. But that, I didn't write this, all right? This isn't my textbook. But this is the way that they chose to write it, to basically say, hey, this is how you do that. Now, imagine if you had this point of this triangle and you got it closer and closer to the base. What would happen to the area? If I went from having this point, I don't think there's a way for me to grab that. I can only grab the whole thing. But let's say I have this point that is up here instead. Did not mean to do that. If this point is here, we got a certain area. But if I start dropping down this point, this vertex, what would happen to the area of your triangle? Would it get bigger or smaller? Smaller. It keep getting smaller and smaller and smaller. Way down here would be really small, right? If it gets all the way down to here where it's on this line, what would happen to your area of your triangle? Because it keeps getting smaller. It's approaching 0, right? So that's called collinear. These 3 points would be collinear. So if you have 3 points, this is another way you could use this. If you have 3 points and you want to prove that they're collinear, you could find the area of the triangle that they create. And if the area comes out to be 0, that means those 3 points were actually collinear. If you get some sort of area other than 0, then that means that point is not on that line and you actually have a triangle with some sort of area to it. So that's why I have that note in here. That's another use for doing this, okay? So, we're going to find the area of this triangle. I'm only giving you 2 points because what's this point?
0, 0, 0.
Yep, that's 0, 0. All right, so it may not be shown, but you can see it's at the origin. So if I want to find the area of this, the area equals plus or minus 1/2, okay, and I'm going to create a determinant here. Again, the right-hand column, no matter what, those are 3 ones. And then you take your 3 points in any order you want. Which one do you want to do first?
0.
You want to do 0, 0? Okay, 0, 0 first. Now what? Which
1, 5.
1, 5?
3, 1.
3, 1. Again, it does not matter what order I do them in, but the order you choose may cause it to be negative. And if it does, you just change it to positive. Okay? So now I'm going to calculate this determinant. So I'm going to forget about this plus or minus 1/2 for a moment. Plus or minus 1/2 times. I'm looking for this value, which is for this determinant here. Okay, so I'm focusing on this. So I'm going to put 0, 1, 3, 0, 5, 1, and I'm going to calculate the determinant. Give me a lot of zeros in this, which is nice. So the first diagonal, 0 times 5 times 1 is 0. Second one, 0 times 1 times 3, 0. Third one, 1 times 1 times 1 is 1. Then I start subtracting. 3 times 5 times 1 is 15. The next one, 1 times 1 times 0 is 0, so minus 0. And the last one, 1 times 1 times 0 is 0, so minus 0. So this comes out to be a negative 14. So which do I use? Do I use the positive or negative 1/2? I use the negative 1/2 because it's a negative number there. So area equals 1/2 times negative 14. The area turns out to be 7 square units, whatever it was. All right, so these, like on a graph board, it basically means that triangle, you could fit 7 1-inch squares inside there if your squares are 1 inch each. Okay? I think that's it until we get to the next part. So we will cover that tomorrow.